Hello and welcome to Func Prog Sweden. First, as always, welcome to all our recurring viewers and meetup members. It's for you we do this show, so welcome back to Func Prog Sweden. And to all our new viewers and participants, welcome to Func Prog Sweden. This is the meetup where we explore functional programming languages, concepts, and alike. And with that, let's head over to today's exciting agenda. First, short introduction by me, Magnus. Then Zerl, making SIG in the beam and ease time by Eduardo Lemos. So we'll get an introduction into how you can put Erlang on Zig. Really exciting. I've seen a snippet of the demo, or the presentation. It's really worth it. Stick around, it's really interesting. Then second presentation, single process microservice architecture using Dapper actors and F# by Jonas Juselius. Also really interesting how we can make microservices with an actor model using F#. And then in the end, we'll do a post-show chat for those who are still interested and want to chat more and hang out with FP people. But first, thank you Idiomatic for the video sponsoring of the meetup. And if you want to know more about Idiomatic, just head over to a browser and check them out either on idiomatic.com or on social media. Then the schedule for the coming meetups. We're back 3rd of December with another meetup, and then next year we already set the date, 21st of January. We will have the next first meetup of 2025, and then we will have a meetup in February. And then in March, we will be back, preliminary in Kivra. So if you're around in Stockholm in March, be sure to check out when we announce the date for the meetup in Kivra, and make sure to join us either in Stockholm or, of course, on the live stream, as always. And if you want to support the meetup, and the meetup group, you head over to meetup and make sure to join us there, and please subscribe to our YouTube channel also, so you don't miss when we release new videos and do live stream. And if you want to hang out with other people doing functional programming, head over to Discord. There is an invite both in the meetup group and in the YouTube channel. You find an invite to the Discord server. So head over there, and you can also ask more elaborate questions to the presenters. Which brings us over to the last topic before the presentations. Questions. If you have questions during the presentation online, please use the YouTube chat. YouTube chat can be somewhat limiting. Then head over to the Discord server if you want to ask more elaborate questions. With that, then welcome to our first presenter, Eduardo Lemos. Welcome to Func Prog Sweden, second time around.
Thank you. Hello,
You're
everyone.
welcome. You're warm welcome, Eduardo.
Okay, so I shall start. So, hello again. This is my second time this year. I was here in April talking about some Haskell. And today we're going to talk about something completely different than that. We're going to talk about the beam. We're going to talk about a little bit about Zig. And I think this is a story worth sharing with you guys. So this is a project from a programming group that I participate. We call ourselves Don't Rely on News, right? And there are many. This group was responsible for this library, which is Zerl, and you can check the logo in the top right corner there. That's the logo of the library. And the purpose of this library is to make a bridge between the beam and the Zig ecosystem. And I'm going to refine what I mean by that, right? And one thing that I think is really neat is that Zerl makes your life easy. And that's why I think some of you guys are going to love it, right? So easy in the title is easy, right? But let's not get ahead of ourselves. I need to convince you why it's easy, right? So a tiny bit of presenting myself. I'm a huge functional programming fan, right? And I played with various languages within this space, such as the ones on the screen: Haskell, F#, Clojure, Racket, Erlang. But most importantly for today, which is the beginning of our story, because I'm going to tell you chapters of this story, is that I'm a huge fan of recreational programming. So recreational programming is, instead of doing whatever you do on Friday nights, you just do programming for fun. And Zerl was born from this idea. It was started from a personal hobby project with my friends, and that got evolved into something a little bit more interesting that we think has potential to help the Zig community to be able to use easily the Beam's capabilities. Because if you're doing any sort of distributed system, you should think about the Beam, right? So if you go to the commit history of the project that I'm about to mention, you see the first draft of Zero, the proof of concept, the tears and the celebrations in form of PRs, and when and how it evolved. Of course, I'm going to tell you how that happened, but you can check for yourself in there if you're curious. The link is in the description below. So let's talk about in the beginning of times, right? So we're going to do a project. We were excited about doing a new programming project together. And there are a couple of questions that always arise that we need to go through to start a project. So, and some of these questions are very tough to answer and they delay some projects in our experience doing recreational programming. One of these questions is what should we make, right? There are many, many things that we can make in the software world. One of them could be making a database. Why not? What about making an HTTP server? What about a classic, a simple toy programming language? And there are maybe many, many more options that we can go through. We can make a Kafka clone, a text editor, a browser, a window manager, a VM. So there are many, many things. But after some discussion, we settled on making a game. We're going to make a game, but that's going to be, it needs to be more interesting. Let's put some more sauce on top of it. So let's make it multiplayer. Let's make it let's do some networking. Let's learn how to do that properly to the best of our abilities. So we settle on a medieval-based, heavy lore game that you can explore with other people. And then it comes the second question, which in my opinion is way harder to answer. Which language should we use to make it? There are many, many languages out there, just to name a few, right? And then there are secondary questions that arise from the first question. What do we want to learn now? Which features are the most interesting? Which language has the best set of features for the thing that we are trying to develop? We're trying to develop a game, right? And this particular game has a plus. It's a multiplayer game, which means that we are not bound to one language choice. We can actually pick two, right? So it doesn't need to be the same language. There's no reason for that. That's not fun. So after some discussions within the group, we settle on this combo here. We're going to make a game, a multiplayer game, in which the client side, the front-end side, will be written in Zig language, and the server side will be written in Erlang. And then, of course, this is a little bit raw. We need some more infrastructure. So let's jump a few steps on the story, and we settle on this combo here. This is the game. This is the final version of the game. And Zero was born because of the interaction between those two. The client, being on Zig, will be using Raylib for the graphics, and Erlang, being the server side, will have to store some data because this is a multiplayer game. You need users, you need characters, you need a world, you need a map, you need to be able to walk around, and this position needs to be saved somewhere. So all of this matters. So we're going to use Postgres for that. And everything will be wrapped inside Nix for reproducibility. And that's our game, right? And that's our game. And the plot of our story, starting from Zig and Erlang, is to answer this question. We settle on using these two technologies, but how are they going to exchange information? How can we do that? So and then other questions started to pop up, like what's the best way of doing that? There may be multiple ways of doing so. So that's why we made Zerl. Zerl was an attempt to answer this question. How should we communicate between the two sides of the game? Because I know this is obvious for some people, but just for everybody to be on the same page, when you interact with the application, something needs to happen on the server side, and potentially the server responds to something that the client needs to react to it. That means that exchange of information is a must-have feature. We cannot do the game without this, and that's why Zerl was born. It was to fulfill this requirement. Okay, and then now that we know why we need it, now we need to define what are the features, what are the requirements that Zerl needs to fulfill, and we settle on two. It needs to be an idiomatic way and a convenient way to exchange messages back and forth between those two guys. Now we need to define what I mean by idiomatic and convenient, right? So let's start with idiomatic. What we want to do, what we're calling idiomatic here, is that we want values of usual, common, and recommended types in one language to be serialized and deserialized to usual, common, and recommended types in the other language. So we want to have this flexibility. The users of each side, they don't need to know about how this is being done. They are just receiving information and sending information using their own types. They need to make an extravagant transformation to do all of that. So let's pick an example, a map in Erlang, right? So think of in Zig terms. What should be the type of a value that is coming, and the value in Erlang is a map? If you're thinking about a map as well, like a hash map, ask yourself, in C, Rust, and Zig type of languages, that's not how we do things. We rather use a struct than a map. I think that's pretty reasonable. So, and because after all, a struct is just composed out of fields with values attached to them. So it's kind of reminiscent of a map anyway. So wouldn't it be nice that when you're receiving data from the Erlang side, Zig just gets a struct already automatically? Wouldn't that be cool? And the opposite also applies. Isn't a tagged union in Zig just a tuple in Erlang? If you think about it, a tagged union is a tag and a value attached together. That's a tuple. So why shouldn't Erlang receive a tuple from Zig if that's the case? So this is what we mean by idiomatic. We want to cut all the possible corners into the serialization layer, so the user of the library can properly have a table of maps of like this type is this type in the other side, and that's it. That's all the information that you need. Everything else is just using the library, which should have a great API to provide that to you. So that's what we mean by idiomatic. And what about convenient, right? So as I'm about to show you, the way that we are doing this magic is based on a C library that comes when you install OTP, right? When you install the Beam, you're gonna have the C library coming with it. And at first glance, it sounds convenient. Someone already made the work for you. There are already functions for that. And okay that there are C functions, but C is not dying anytime soon, right? It's pretty safe to say that these will last forever. But that's not the correct answer to that, because it's C implementation, which means it's very verbose, error-prone, and inconvenient. And I will demonstrate that to you. And I hope I will convince you as well. So Zerl wants to go the opposite direction of the C approach, which is trying to not do the way that C does, because again, as I'm about to show you, it's very inconvenient and annoying to use. And another thing, to make it convenient, the setup to use the library needs to be the smallest as possible. What I mean by that, when using the library, we want you to just focus on sending functions and receiving functions. That's it. You don't need to do anything else. You don't need to call something else before or after. No, none of that. The least amount of that, the better. So now we're going to go through the iterations of the library, right? So there are three main iterations, three main plot points of this story that we went through when making our application. So what would be the first approach in your mind, given what I just told you? just do the C approach, right? Zig has great interop with C. Why not just do that? And we're gonna go. We're gonna answer why this is not a good idea shortly. Um, so this is again the C library that comes when you just install Erlang. In any, as far as I can tell, in any system, it will come this with it. And I also need to put a side note here, a disclaimer. The code I'm about to show you here is just the code to send a message. We're not going to talk about establishing a connection with the node. We're going to talk a little bit about that later. But for now, just to prove my point, what I will do is to just show you what's the work that you need to do to send something using the C library. So let's get started. So let's suppose that you want to send a string to Erlang. And let us model that in Zig, a string as a slice of bytes null terminated. And because we're only going to read it, it's going to be a const. So it's pretty fair. So you can see the type signature, we are receiving the node, which again, as I mentioned before, we already established connection with the other Erlang node. And we have our payload, which is the message, right? Which is the string. So what do we need to do? What is the instruction set to use the library, the C library? So the first step is to create a buffer, because the C library wants you to keep appending data to this guy, and then you just send the buffer at the end. That's what you're supposed to do. So in line 6, we are creating such buffer, and as you can see, in order to send just a simple string, there are more things that need to be appended to the buffer, which is going to include the version, and then we also want to send to the Erlang our own identity, right? Because the server needs to respond back to us. So we can't just send a string. We need to send our own PID. So that's what we're doing in line 9. We are putting into the buffer our own PID, grabbing it from the node. Then we are transforming the slice of bytes to an atom, because at this moment, that's how we serialize strings. And so that's it. We are just appending a tuple into our buffer. And then I want you to keep track of a few notes here. What happens if you swap the order of line 9 and 10? You are sending something completely different. You are sending a tuple that the first member is the message and the second member is the PID. So a very small detail that you miss and you swap by accident, everything's going to blow up. It's done. Second detail that I want you to pay attention. Notice that from line 7 to 10, there is an underscore equal. Why is that? Because these are C functions. If you know C, you probably have a good guess on what these functions are returning. They're returning negative values, negative integers, which means that for each call of this, you're going to have to do an if to check the response of it and throw potentially an error. Imagine the boilerplate of that. This is just to send a string. We are not sending any complicated payload whatsoever. And all of this code is necessary to send a string. And yes, in this particular case, I am ignoring the errors. We should treat them, but the boilerplate would be too big to fit in my slide. So I actually decided to not put it in here. So at the end, after all of that, we actually send the data. In this one, we check the result, actually. So if the sending failed, we just throw a Zig error, which are way better than negative integers from C. And then ask yourself, after all of this, is this worth it? Is this really worth it? All of this work just to send a simple string. That's not cool. That's not nice. That's not idiomatic, neither convenient. So the answer is no, it's not. And it gets worse, because here's a little bit more complicated example. Now we're not going to send a string, we're going to send a struct. And as I mentioned before, a struct will become a map in Erlang. Right. So we do the same process, right? We do the same process. We start creating our buffer. And we need to append the version, and then we need to inform what is about to come. We're going to do a tuple again, so we need to do on line 10 the tuple header. How many elements we have in this tuple? 2. Cool. We're going to send our own identity. We're going to send the PID, right? because again, the server needs to know who to send the response to. Then it comes a map header. Why? Because this is a struct. This is user registration struct. So we need to start informing that we are about to append to the buffer the map. Then every single value from lines 13 onwards is a pair. So you put key value, key value, key value. So the first thing is an atom saying action, which is the key for the value for the atom registration. What are we doing here? We are informing the server when reading this map that the action that we're doing is registration of a user. And then it comes the email, the username, and the password, all of those things that the user put in the Zig client. So far, so good. And then we append all that stuff. Again, I'm ignoring all the negative possible errors, the negative integers. And then we send the data. Then we send the data. And again, if you swap any of these lines, and actually it's worse here because now if you swap the map header and tuple header, all of these will get completely nonsensical to the server side. And it is very inconvenient because for every single type, being a string, a user registry, a character creation, a character update, you're going to have to write one of those for every single one of them. And that's very inconvenient and very annoying. So after playing around with this for a bit, we came up with the second iteration of Zerl. We came up with using intermediate representation plus an interpreter. So what's the drill with this one? So the main idea is that we're going to create a type that will mimic Erlang's data in Zig itself. We're going to call that Erlang data. And then we're going to make an interpreter that will recursively interpret the value of this type and do the proper boilerplating. So as you can see in lines 5 and in line 3, this is a recursive type because you can have a tuple that has more Erlang stuff inside it. And the same applies for the map. So once this time, we grab the buffer that we're going to create somewhere else, and we grab the data, which is a payload that can be recursive, and we're going to interpret it, right? And if you ever played around with any toy interpreted yourself, you know how to do this. It is just a matter of matching the data, doing the stuff correctly, the interpretation correctly, and calling yourself recursively if you need to. That's it. And this version also received an upgrade. Look at line 12. There is a function now called Erlang validate that does the validation of the negative integers. So how this function works, you pass the error that should be thrown if you had a negative integer. In line 12, we have encode atom as the error message, as the error value. And you pass also the attempt of encoding something. And then you put the C library there. You plug the C library there. And you do that for all of them. So line 15, line 24, line 32. We are just calling C libraries in a little bit more fancy way, because then we can reduce the amount of error proneness of the previous approach, of the C approach. And of course, now that we are doing this validation here, we can also just throw Zig errors instead of using the integers from C. So then you ask yourself, what's the problem with this version? Why we didn't settle on this? Because this is still annoying. You know why? Because nothing comes for free. You don't have an Erlang data, right? You have your application structs and types that you're using to make the game, such as user registry. What that means? That means that in order to get into the intermediate representation, you need to translate that yourself still. In this particular case, we are creating the Erlang data based on the user registry struct that I showed you earlier. So, and then additionally, we have a little bit of a helper here. In line 2, we have a function called send with self, which is receiving a node. This is just putting a tuple with our own PID on the left, just for convenience, because you're going to have to do that every time. Because again, the server at this moment, the server needs to know who is sending the message. And once again, you need to do that for all your types. You need to do this for every single struct, enum, tagged union, every time. And what's worse, if you change them, let's suppose that you had an initial struct and then you started programming around it, but then you change your mind. This is not good enough anymore. You change it. Now you need to go here and change it again. You need to remember, right? Especially if you're just adding fields, you're not replacing them, you're just adding more of it. This will not break, but it's sending incomplete data, and you're going to have to remember that. So after this second phase, we came up with our final idea, with the final core idea that is currently implemented, which is a compile time reflection-based interpreter. So that's a lot here to unpack. So let's go bit by bit. Let's start by talking about reflection. What is reflection? It is, in summary, in programming at least, it is the ability of a process to introspect and potentially modify its own structure and behavior. So in our case, we write Zig programs that are capable of examining Zig structs and potentially other structs from other places, other types, but we will be able to inspect them. We're going to be able to look into them. And you're going to understand what I mean by that shortly. Next up is a compile time. What do we mean? This means that things will happen before the program actually runs. This will happen at compile time, at compilation time. And this is handy because then you can be certain that some parts of your program that you're manipulating are correct at compilation time. And then you may ask yourself, how can that be done? The program is not running. How do you know the data? Sometimes you do know the data. You sometimes have global strings, global structs, global values that can be known statically. And then these can be evaluated at compile time. And this will be important later. And in Zig in particular, because this the reflection is happening at compile time, this is a way that you can implement metaprogramming, which is way better than have a preprocessor like in C. But last, but definitely not least, an interpreter. So we will create a program that receives some sort of AST of some nature, and we're going to interpret it. If you ever did any hobby side toy programming language project, you know the drill of this one. So let's now put all the pieces together to know what exactly I'm about to show you. We will make an interpreter in Zig that uses compile time reflection to inspect something at compile time and interpret it. First question, what will we inspect? Zig's own data structs and Erlang's. So we are talking about PIDs, Zig structs, Zig enums, Zig tag unions. Second question, what would be the act of interpreting these things? What would be the effect of doing so? Because in some interpreters, you actually do an expression reduction, right? This is the act of interpreting. But here, we're going to call C functions. The act of interpreting this data, these values, will actually trigger call of C functions that I just showed you before. And you know what's the best part? This thing works both for the receiving and for the sending of data in Zig. So now I've only showed you how to send stuff. This strategy, the third one, the final one, works for sending and receiving. So now I will show you some snippets that are closer to the version that is currently implemented, so you can get an intuition on how it works. We're going to focus on receiving this time, just because sending with this strategy is a little bit more extensive and it's going to take more space on the screen. And yes, you're gonna. It seems complicated, but trust me, it's not that complicated. So let's start with the type signature. This is receiving, remember. So first it comes a decoder struct. And what is that? That is a struct that contains information required to decoding. Remember from the C approach, we have a buffer. We can't get around that. We need a buffer to keep appending data to it. So this will live in the decoder struct. And then we're also going to receive a type, right? We're going to receive a type. In Zig, you can actually treat types as values, and that's why you can we are able to inspect them. And why we're going to do this? Because only the caller of this function knows that, oh, the type that I want, the data that is coming from Erlang, I want it to fit in this shape, in this mode. Is this struct, this enum, this tagged union. You need to inform that to the deserializer. You need to inform it to the decoder. So then you will attempt to create the value of such type. You can actually check that out also in the return type. There's an error exclamation mark, which means that we may error out doing this, but there is a T there, which is being introduced before. This is basically introducing a type variable. If you ever played with OCaml, F#, Haskell, you know what this means, right? But here the difference is that we are receiving a type variable and returning a value of that type, which is different. And of course, we're only going to return T if we don't error out. So this is the main entry point of the decoder, which again may not be the current one at this moment because we made some improvements recently. But the point of this guy is to have a bunch of high-level checks, right? And then we're going to call smaller functions according to these checks. So the first question, what are we trying to decode here? What is the application programmer asking for? We will use the T, the type that we are receiving to answer this question. So the first check is to check for strings, which again, we are modeling as a slice of bytes, no terminated, reading only. We check that. If that's the case, we're going to call the parsing string function accordingly. Next up is to check if it's an Erlang specific type, because we care about PIDs. So we are just asking if T is that, right? And I want to highlight a pattern in this implementation here. So you see on line 5 that you're creating something that we are calling a value. And it's a var, which means that it's mutable. This is of type T. We don't have data yet there, which is undefined, but we know the type of it, which is value. Then on lines 6 to 9, we're actually calling our validate function from before. And look at line 8. We're passing a pointer to the value. So what is it doing? It is picking the data from the decoding PID process, putting it in value, right? And we're gonna return this value later on. So this is a pattern that we use quite often. And finally, this is the main check. We ask for more information of the type T using the built-in type info there. And then we are checking. You are a Zig guy. Who are you? What is your type? What is your extra metadata information of your type? Are you a struct? Are you an int? Are you a float? Are you a pointer? Are you an enum? And so on and so forth. And then we just gonna pipe that to the correct parsing function accordingly. I will show you two very easy examples of these guys, just for the demonstration purposes, just so you can have an intuition about it. It's very similar to the PID example. So I'm going to show you how to parse a Boolean, how to decode a Boolean, and how to decode an enum. And again, these are not final versions, especially the enum case, but they are enough for you to understand what type of magic this library is doing. So let's go through the parse Boolean first. So parse Boolean only receives a decoder. Why? Because we don't need any extra information from the T type from before. We know we're going to return a Boolean. Look at the return type. It may error out, which means error exclamation mark, but it has a bool there. Then we do the same pattern once again. We create a var. We know that it's typed this time. It's a 932. You may ask why, and the reason is because in C there's no Booleans. There are only integers. So we are just respecting C's limitations in this case. We try to decode it on line 5, decoding the Boolean, putting the thing on the bool value, and because this is C, the return on line 7 is just a comparison with the 0. And that's it for the parsing, decoding a Boolean. That's basically it. Now a more interesting case, parsing in enum. Once again, the version here is not the current version on the library, and the reason is because the current version is doing a lot of more checks for you. It has some corner cases in this version that I'm showing you that are not being fulfilled. But again, this is the core of the process. This is the heart of the process. So first thing that you may notice that is difference between the parsing boolean and parsing enum. Parsing boolean only receives the decoder. Parsing enum receives the decoder and the type T again from before. So if you go back and you take a look on line 19 and on line 15, you're gonna see that 19 doesn't receive anything, just receives a decoder, which because of the dot notation, we don't need to, we can use it like that, like just self dot something. But line 15, we are passing the T. So this is what's coming here. And you may ask, why that's the case? The reason is because what are we trying to achieve? We're trying to receive something from the Erlang side and transform it to an enum, right? A particular one, not a generic one. It's an enum specific to for our application. How can we know the values of an enum? The possible options, right? They enumerate. We need to ask the type. The type knows that information. And that's exactly what's happening in line 14. So we are doing a for loop, iterating through the available possibilities of the enum. Of course, we need to get an item first, which is being done in line 11, which is just, again, using the built-in type info. We know it's an enum, so we can just do dot enum on line 11. Then on line 12, we get the stuff from Erlang, because at this moment, the enum is just an atom. Then on line 14, we are just iterating through the possibilities. On line 15, checking if we match one of them. If that's the case, we try to pick the string, transform it to the proper enum, and return it. If this for loop goes through, that means that none of the available options for the enum that you specified came from Erlang. And then we're going to error out on line 19. So as an example of a check that should be here, and it is right now, but not in my slide, is, do you know that an atom in the beam has a fixed maximum limited size? That's an information available in the documentation. You cannot have a ginormous atom, right? So we are doing that check for you. If Erlang is trying to send something that, well, if you're trying to receive something from Erlang that is bigger than what is available on the beam, it will error at compile time, which is way cool, way cooler than not doing it. Trust me. And now we're going to go through the example that is written in the repo. So there are two available examples there. I'm going to show you the simplest one, and you can run this by yourself. All the setup is already provided. You can just do zig run server, zig run well, client, or whatever it is, and it's going to work fine for you. So this is the hello world example that is provided in the library itself. That's again available in the link. The link is available in the description. So reply here is going to be the reply from the server. This is a simple program, a hello world program. We're going to just expect as a reply an OK, which is a tagged union, so it should be an OK tag and a string as a value attached to it. So the first thing that we do is a little bit of a setup, right? So we create an arena, we're allocator, we set up the std error, we print that we are about to run the example, all that stuff, pretty normal. And then it comes the cool part. The first thing that we do is to attempt to initialize our own node, because Zerl is already doing a wrapper of creating a node for you. So line 17 is initializing everything that needs to be initialized. Then in terms of the C stuff, right? You can see that it's Zerl.ei, so we are actually calling the init function of the C library. Then we do our own init on line 18, which is putting a cookie in there. Then on line 19, we attempt to establish a connection. We call the function, send our node. We are trying to connect with the server name, a server named hello on the address localhost, which again you can run yourself. It's locally reproducible. Then we're gonna print in line 21 that we connected. If you went through this, if the try went through on line 19, that means that we successfully established connection. So next up, it's actually sending the data. We're gonna send the hello world message. So what are we gonna do? We're gonna we're gonna grab our PID on line 23. Then we're going to create our payload, which is going to be a tuple containing our PID and the string hello world. And then the zero.with PID there is just a helper function to make that a little bit nicer. And then on line 25, we are sending to a process named echo, not a server name. There's a difference here. On line 19, we are putting the server name that Erlang, you can put in your rebar 3 configuration. And then there is the process name called echo, and we are trying to send a message to echo. If we went through from line 25, that means that we sent it successfully. The process worked. And then the final piece of the puzzle, receiving the response from the Erlang side. Lines 27 waits for the data. And look at the pattern there. There is the reply struct, well, the reply tagged union that I explained before, which is telling Zerl how should what is the mode of the data? What is the mode of the data? And for receiving, we also allocate some intermediary data. So we need to pass an allocator. In this case, we are passing an arena. And then on line 28, we are just replying the value, right, the string from the OK tagged union. And then on line 29, we're just asking the server to finish its operations. And that's it. That's how you use it. That's how you use Zerl. So now let's go back and see if we accomplished our goals with the third strategy, a compile time reflection-based interpreter. First up, let's check if it's idiomatic, right? Well, in the current iteration, we covered these important cases here. This is far from done. There are many other public exceptions to rules and mappings that we need to get done. But these are the current translations that we support. And I would like you to pay attention to the slice of bytes in Zig. It becomes a string. An enum becomes an atom in Erlang, or in the beam, I should say. And a tagged union in Zig will become a tagged tuple or an atom. And then you may ask, how come? It's because a tagged union can have a value of void, right? You can have a tag and no value attached to it in a tagged union. And if that's the case, Erlang will treat it as will return you an atom. The beam will return you an atom. The beam node, I meant to say. So now we go to convenience. So that's it. The code that is highlighted right now, it's all the code that you need. You need to do a little bit of a setup, right? You need to create the node, establish the connection, but you do that once. That's it. Of course, if you want to change the server, you're going to have to do this one more time, but that's expected. But now, let's look back of the previous approaches. There's no order, right? In the C approach, there was the ordering problem. You swap the lines, you're done in serializing the data, sending the data. This is not possible here anymore. This is not possible anymore. Second, there are no negative integers, so that's a plus. And third, you don't have to write this for all the types that you are making your application. You can have 1,000 structs, 1,000 tagged unions. That doesn't matter. This will always work. Of course, assuming that we are supporting a particular case. And as I said in Idiomatic, this is definitely not the case yet. And again, as another plus, there's no intermediate representation, right? You don't need to care. You only have the data that you care for your own application, and that's it. That's everything that you need. So now, a non-trivial example. Now we went through how it works, the story behind it, a hello world example. But what about a more complicated instance of this, the use case of this? So this is the game that I started the story talking about. This is the game. It's running. As you can see in the bottom left corner, we are connected. And I'm not going to show you how to connect because we have a public IP in there. And well, people may try to connect to it. So what I'm about to do here, I will log in and I will mention specifically which parts of this process is using Zerl. So let's get started. So the first process is to log in, right? So I'm going to put my user here. And yes, making the password redacted is a to-do. Be patient with us. And we're going to try to log in. What would this do? This will we use Zerl as the bridge to talk to the Erlang server that is running in an instance in São Paulo right now. And we'll check the database to see if these credentials are valid. That's what we will do. And then it will answer back to the Zig application, establishing if everything is okay to proceed. So we got an error there. We got an error there. So let's try different credentials. And of course, this is the problem of doing live demos. Yep. So something happened with the correct thingy. Let me try to fix this real quick, because of course this would happen. Okay, it was just a timeout. Thank you. So if you do the login, which I can actually show you, right? I did login, I pressed OK, and then you went to this screen here, right? You will go to this screen here, and then I can pick a character here, right? And what will this do in terms of using Zerl? It will tell that I'm about to join the map of this character, because when you're creating a character, you also pick which map this player will be playing in, and I'm going to spawn in there. Okay, here I go. So here I have a friend, right? This is my friend Benevides, right? And for each thing, so let's go through what is using Zerl in here. When I ask to join a map, what is actually happening is that we go to the database and say, what are the configuration of this map? What are the tiles? What are the objects? Because you have some objects here. We have a chest here, right? We have a chest. We also have a tree, right? This is all in the database. So then we do a query on Postgres to select the stuff for this particular character, and then we dispatch it via the wire to the client. The client reconstructs that map as it is using the correct assets. So another thing is the information of the other players, their positions, their velocities, their levels, their names. Everything is using Zerl. And every time I walk, I'm also dispatching an update to the server, updating my position in the database. Because if I log out, right, and I log back in, my player should be exactly in the place that it should be. The stats that I have up there, I have 67 of health. This is also in the database, so this is also using Zerl. And right now, this is a 60 FPS game. So this means that we are talking with via Zerl with a server every 16 milliseconds. Every 16 milliseconds. So this is an Erlang server running in São Paulo right now as we speak. There were 3 players at some point here. Another friend of mine joined, and then he left, and we got updated about that he left. He's not longer here with us, right? And yeah, and then you can also see that the minimap also responds to our positions, right? This is also because of Zerl. This is because of the position that we are being updated constantly. I can quit the map, right? I can quit the map. I can log out here. Quitting the map also uses Zerl to communicate. Because we need to tell the server that we're not playing anymore. And why that's important? Because somebody may be playing and I need to vanish from their side. So that matters. And logging out is also important, pressing this button, because that means if I was not logged out and somebody opened a client connected to the address of the server and tried to log in with my account, they can't do that. So the way that I allow them to do that is logging out from my side. Once you're logged in, you have to log out. So that's the demonstration. That's the demonstration of the game that is currently already working. It's also in the video description. And then to finish my talk, we're going to talk a little bit about the drawbacks, because nothing is perfect. And Zerl is far from perfect. In fact, it's far from perfect. And it's very much a work in progress library. So let's go through the main core problems of it, which are these three: inflexibility, specificity, and incompleteness. So first of all, flexibility, which I think is one of the main protagonists in comparison with these three. Have you noticed that there's no timeout functionality? If you are trying to send stuff and it hangs, the entire application is hanging. That's it. There's no way around that. At least at the moment, you can't do anything about it. You need to do the timeout functionality yourself in your code, which is annoying, right? So for production use, this being simply absent is a no-go at all. What about a retry strategy? What if you failed after a timeout and you want a very convenient way to say, okay, if it fails, try this retry strategy right here. Try these many attempts. There's no way to do that currently in the current implementation. So that's it, right? So that's it about flexibility, the lack of it. And now specificness. So Zerl was born to attend the demands of our game. That means that we may have took decisions, we may have made the design tailor made to fit and best accomplish our goals of making our game. So for instance, we are using a cookie to establish the initialization of the node in Zerl. We are dispatching a process name or a PID, but are those the only available options? We should try to go outside of the game's needs and try to make it as generic as possible for the most popular use cases of using a beam node. That's one of the drawbacks of this. And finally, it's incompleteness. As I said in the idiomatic session, we are accomplishing quite a bit. You can do a game with it, and that's cool. But we are far from done. We are far from done. So you can check a more thorough review of the incompleteness in the repos documentation. But I will mention some of them in here. So from the beam side, no big integer support, no binaries, incomplete support for records. From the Zig side, incomplete support for extra structs, no isolated options, no error unions at all. All of these are unsupported from both sides. And it's not 100% clear to us exactly yet what should they become. Because, again, this is a mapping between things. So we need to know the two sides of the coin. And some of them may be must-haves for some applications. In our game, we're not using big integers. As far as I remember, the maximum thing that we are using is a 32-bit float. But maybe you need more. Maybe you need way more. How should we accomplish that? We definitely should, but we need to think about it, implement it correctly, and make it more complete. So that's it. I presented to you Zerl, which is brought to you by Don't Rely on News. If you feel like this is a worthwhile library to enhance, feel free to talk to us in GitHub via issues. The repository is public, and we are very excited to fix the drawbacks. Thank you. That's it for me.
Thank you, Eduardo. Very impressive. Good presentation. Also good catch, even though the the login didn't work first time around. Very nice.
I probably got timeout.
Oh yeah, my guess is also you got a timeout. Well, you kept it cool. Yeah, people are clapping in the chat. Really impressive. I also liked your in the beginning, like recreational programming, just doing it for fun. I think that's something. I don't know. It was a long time ago I did that actually. That sounded really nice. Just hacking
Some
away
people
on
have
something
happy
for
hours on
fun.
Fridays. I do recreational programming.
Yeah, but it's nice. Just hack away on something and then don't think too much about it. It's nice. Um, cool. So what's the next step for the Zerl?
I would say that our next step probably is going to be to address the two the first and the third drawbacks. So the first one about the timeout functionality, and about having more production ready features. I think that's a must have. Like we cannot we can't ship this to a real world software solving problems without having timeout. I think that's problematic. Then the third one about the big integers and the lack of support of types in both sides. I think specifically the big integers, I think they may be the most important at the moment because before it was the long longs, but we solved this 2 days ago. Uh, and I think now the mapping of that is it may be the second step. The second drawback about the specificness, it's not really clear to me yet because well, I'm biased. I made the game, so maybe we need to discuss a little bit more thoroughly about that. And well, we are open to ideas. If people have better ideas to improve the library and make it more convenient to use and put the beam on the radar for Zig people, I'm down for it. So if any other ideas pop up,
You heard him. If you have ideas, go into GitHub and post ideas to Eduardo and the team.
yeah,
Yes, thank you very
yeah.
much, Eduardo. I'm checking.
And speaking about the team,
Yep.
speaking about the team, one last thing that I would like to say is that I'm for recording purposes, I'm pretty thankful for the people that worked with me to develop this library and develop the game. You guys are awesome people. That there's a reason that I want so bad to work with you guys for the longest that I can. It was a pleasant experience, and this presentation was possible because of you guys.
Nice. A big shout out to the team. Thank you very much, Eduardo. Again, thank you very much for your presentation.
Thank you very much for listening.
No, it was super exciting. Thank you.